One of your key responsibilities is conducting simulation studies on crack formation and propagation in eco-UHPC. How do these simulations help predict material performance in harsh marine environments, and what challenges have you encountered during this process?
One thing, very important thing is that we need to understand that behavior of our materials or our structures are has to be understood. Yes, we have to follow them. We have to run tests, mechanical tests, and see how is the material or the structure behaving in time or in the early age and after some weeks or months. But this is very important. This is fundamental, but we need, but it takes time. First, it takes time, a lot of time. It takes money. It's tests, running tests in laboratories, taking money, taking the time, and we cannot do or run all the tests on all the scales if you change from laboratory to structure to real scale structure panel. So we need always in our domain of research, we need to simulate also what we are doing, the behavior of our product or structures or even the materials. So this is why we are always running simulation parallelly to tests, to mechanical tests. So simulation is helping us to predict, because we can, since we know or we have this first tests, and we know what are the main parameters, the more important parameters and laws to use. The second step is to introduce them in softwares, like for our case, Castem, for who know about this softwares, or Abacus. Abacus is more famous maybe. And this software, we have to run tests, numerical tests, to simulate the behavior of our materials or structures, and follow the damage, introduce laws of damage, introduce parameters to characterize something is important, a behavior or a behavior law for our structure. And this is helping predicting and saving time and saving money and doing things sometimes we cannot do simply we cannot do, because like a harsh lab, we can put small specimen in harsh lab. We can do some tests, but it's not easy to run as many tests as we want, as many samples, and wait for time to see if damage is coming, if strength is good or not, what is resistance, residual resistance after a certain time. So we need to simulate all that things. From validation we do on tests in the lab. We validate those tests on specimen, maybe small specimen, and repeated tests. And after that, with simulation, we can go to things we cannot do sometimes, because it's difficult, or if we have to put the sample, the structure in the sea, for example, for our case, we have to run a lot of simulation before to be sure that what will happen in the sea is predicted, is is known a little bit. And sometimes we have to be sure that our simulation fits to our experimental results. This is what we do in the first step, which is a step of validating the models, the simulation. And running simulation can be done for other scales, for other for extrapolation, if you want to, if you can see, for this from this small specimen. So simulation is very, very important for us.